Section 1.3, Linear Relations. Well, what that means is we're going to have lines. So here is a line. And the directions are, use the graph below to answer the following questions. Write each solution as a point. First question asks, determine y when x is 4. Okay, so I'm going to start on my graph. I'm going to start at the origin. And I'm going to go to where x equals 4. And then I'm going to go and hit the line. So I come down here, right here where I hit the line. And it wants to know the y number. So I go back across. It looks like y is -4. But it asks me to write my solution as a point, so I'm going to write it as 4, -4. Remember, we always put the x value first, and then the y value second. All right, question B. Determine x when y is 6. So again, I start at the origin. I go up to where y is 6. And then I go over to my line, so I'm right here. It looks right there that x is -1. So again, I write that as a point, -1, 6. And we continue. Pretty similar problems here. Determine y when x is -1. Okay, so again, I'm going to start by going to where x is -1. X is -1 right there. Well, we already know the answer to this one. Y is 6. We already found that point. Y equals 6. So I write this as -1, 6. Next one. Determine x when y is -2. Okay, so y equals -2. That's here. I come over to x. It looks like x is 3. So that's going to be x comma y, 3, -2. Okay, finally, determine the x and y intercepts. Determine the x-intercept. The x-intercept means where this line crosses the x-axis. And that happens right here. Now, I'll see an awful lot of students write x equals 2. And that's okay, but I really want your answer as a point. And there are reasons for this, which we're going to get to a little bit in this section here. So I really want it as, this is the point right here, x is 2, y is 0. So the important thing I want you to notice is, for the x-intercept, the y number turns out to be 0. Conversely, when we find the y-intercept is where we cross the y-axis. That looks like it's happening right here. And again, what I'll see is a lot of students write 4, which is kind of bad, actually. Slightly better is I'll see y equals 4. That's okay, but still I really want it written as a point. 0, 4. And again, we'll see y here in a little while. Okay, so there's problem 1. Problem 2 is almost exactly the same. You're going to take this one and you're going to do it at home, and you're going to bring it to me in class. Okay? So I've printed this file off for you and passed it out, but I'll show you all the problems just in case you're lost it or don't have it. Okay, there's the graph again. Okay, problem 3. A little bit of an application here. It says, water is steadily pumped out of a flooded basement. Let V be the volume of the water in thousands of gallons that remain in the basement T hours after water began to be pumped. A linear model for the situation is shown below. Okay, so notice that we have thousands of gallons on our V axis this time. We're using V instead of Y. And we have hours along our T axis. We're using T instead of X. We don't always use X and Y. In this problem, using T for time and V for volume makes a lot more sense than using X and Y. Okay, so how much water is in the basement 2 hours after pumping began? The important thing here is 2 hours, which means they've given me a time unit. So they've given me 2 hours. So I go to 2 on my hours axis, and I go up And, you know, we make our best guess here. It looks like, come over here, 18 would be a reasonable answer. If you put 17, that would also be a reasonable answer. 19, anything in that region would be a reasonable answer. You don't always get an exact. So we would have V equals 18,000 gallons. Alright, so we might write that as a point. We might write it as 2, 18. After how many hours of pumping will there be 5,000 gallons remaining? Alright, again, this time, the important thing to notice is what they've given us. They've given us 5,000 gallons. That's a gallons number. Now, the big mistake I'll see a lot of people do here is they'll come over here and they'll go, well, I get 5 and 0. Except it gave us 5,000 gallons, not 5 hours. So we need to go to the 5,000 gallons and come over to where we hit the line. And it looks like it's just a little bit more than 4 hours. There's 4.5 hours. So I'm going to say maybe 4 hours, 10 minutes. And again, anything reasonable there would be a correct answer. If you were to give me 4 hours, 15 minutes, I would mark that correct. 4 hours, 5 minutes, anything close, you know, sometimes that's the best you can do is approximate. So we approximate it. Okay, what is the v-intercept? The v-intercept means when we cross the v-axis. So we look, and it looks like it's happening right here, and I would write that as 0, 29. Again, I really want these written as points. And it's important to write it as a point for the next part. Explain its meaning. 0. 0 is our time. So this is time 0. That means right before we turned on the pump. So right before we turned the pump on, there were 29,000 gallons. And that's what I mean when I say explain the meaning in the context. So there were 29,000 gallons when the pump was turned on. Okay, and that's why it's important to have both the X number and the Y number. That's why it's important to write it as a point. Alright, the same with the t-intercept. What is the t-intercept? That's where we cross the t-axis, which is right here. This is the point 5, 0. Explain its meaning. Well, 5 is the hours, so that says in 5 hours. 0 is the amount of water. All the water is pumped out. Scroll up a little bit here. All the water is pumped out. Alright, again, that's why it's very important to write these as points. They have an X value and a Y value, in this case a T value and a V value. When we want to talk about what these mean, and we're going to do that a lot in this class, it's very important to have both the T value and the V value. Alright. Problem 4 is a very similar problem. And again, this is going to be one that you're going to do at home. Let E be the college's enrollment in thousands of students at T years since the college began. A linear model is given below. And it asks you to predict the enrollment at 7 years. Predict when the enrollment will reach 20,000. And finally, what is the E-intercept? Alright, again, that'll be one that you'll do at home, and you will bring that with you to class. The last thing we're going to do in this section is put together what we did back in section 1.2 with what we've learned here in 1.3. In other words, we're going to be given some data. We're going to plot that data, making a scattergram, and then that data should fall into a nice linear model, and we'll see how it goes here. So we have some data. Let G be the number of gallons of gasoline that remain in a car's gasoline tank after the car has been driven d miles since it was filled. And you can see the data. First thing I notice is D is my independent variable because it was given first. So I'm going to label miles on that axis. And gallons is my independent variable. So I'll label that one as gallons. And it might even be a good idea to put the variable here. Okay, miles. Well, it seems like just going 40, 80, 120, so on and so forth makes a lot of sense, since that's how it was given. And here, low of 1, high of 11. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not too happy with that going up off the graph. So I'm going to go 2, 4, 6, 8, 10 to make it all fit on my graph. I think if you went 1, 2, 3, 4, 5 here, it would probably be okay. But I'm going to go 2, 4, 6, 8, 10. Okay, so I have 40, 11, 89, 127, 165, 203, and 241. Now what should happen is those points should fall into a line. Mine's not perfect, but it's pretty close. It's not perfect because my graphing wasn't perfect. I'm going to use a ruler, make a line, and you know I missed a point here, so you cheat and you make the dots a little bit bigger so that it hits the line. That's not really what you're supposed to do, but we'll call it close enough. Okay, estimate how much gasoline was in the tank after the driver has gone 140 miles. So let's see, 120, 160, 140 is right in between. Come up here. Looks like it's about 6 gallons. And that makes sense. If I go back to my data, 140 would be right in between here. So right in between there, 6 gallons looks believable. Estimate the number of gallons driven since the tank was filled if 12 gallons remain in the tank. Okay, so now it's giving me gallons, 12 gallons. So I go up here, 10, 12 would be right there. Come across, I estimate, looks like maybe 20 miles. And again, I think that makes sense here. To have 12 gallons, we're gonna be gone less than 40 miles. So 20 miles looks reasonable. What is the D-intercept? Okay, that's where we cross the D-axis. Looks like it's right about there. That's a little bit more than 240. Let's call it 250. And again, I'm going to write that as a point. 250, comma 0. Explain the meaning in the context of this problem. Well, this number is miles. So in 250 miles, no gas left. Okay, gas left in the car. Finally, what is the G-intercept? Alright, well I look at my graph. The G-intercept was where we would cross the G-axis. That's 10, that's 12. A little more than 12. That would be 14. I'm going to call it 13. I'm going to round it off. It looks like it's actually a little under 13, but I'm going to round it off. So I'm going to write that as 0, 13. And what this means is if I've driven no miles, I have 13 gallons. Well, but that means that's how much gas the car can hold. So I fill it up, my car has exactly 13 gallons in it. So filled, the tank holds 13 gallons of gas. Okay, the last problem in this section, again, this is one that you're going to do. Very, very similar. You have a word problem here. You're given some data about altitude of a hot air balloon. Almost exactly the same thing. You're going to figure out appropriate scaling and draw a graph. Then you'll be asked some questions. Estimate the balloon's altitude after 5 minutes. Estimate when the balloon will be 200 feet in the air. Find the two intercepts and explain what they mean. And again, you will take this problem, you'll do it at home, and you will bring it to the next class.